Hey guys, so today we're going to talk about direct proportion, which is part of rates and ratios. The aim of this video is that by the end of this video, you should be able to find the universal formula and unknowns for questions that involve direct proportion. Now, all of these words may mean nothing to you right now, and you may be a little bit confused, but as we go through the examples, everything will start to fit in place. So let's start with, what is direct proportion? Well, direct proportion is when an object or a shape has the same amount of change, whether it's increasing or decreasing, in all of its parts. Another way of saying it is that as one amount increases, the other amount increases at the same rate. And that's why this is part of rates and ratios. Now, the symbol for direct proportion is there. It looks like a fish symbol. It's not the infinity symbol. It's like a little fish symbol with the ends open. Now let's go through the steps of proportion. You should write these steps down, and then when you do an example, rewrite the steps in your own words. So let's start with the first step. The first step is to write your proportional statement. And for example, if x is proportionate to y, we write x proportional symbol y. So if you write your proportional statement first, then it makes sense to move forward. After you've written your proportional statement, you replace the fish symbol or the direct proportion symbol with equals k. For example, first it was x proportional y. Now we replace that symbol with equals k. So now x equals ky. What does k represent? Well, k is a constant. And we use these terms because constant means something that stays the same, while a variable is something that changes. So the k value in this case stays the same no matter what. And that's why we call it a constant. Now, some of you may be asking, well, why is the letter not C? Well, that's because we use C in other topics of mathematics. One of the most common examples of C is in the accounting part of mathematics, where we use C for cost. So here we use K to represent the constant. Once you have replaced with equals K, you substitute whatever values you know from the question for the variables. In this case, x and y are variables. They will change, and k will remain the same. It's a constant. The question will give you values to substitute in, and you substitute them into their right place. When we do an example, that'll make sense. Once you have substituted the values in, you have to find the value of k by using equations. So we have to get k by itself. Once you have k by itself, you can then write your universal formula. Now, the universal formula refers to the formula that we can use to find other unknowns. It will be universal for that case study, for that exact scenario. That's why I like to call it the universal formula. Once we have the universal formula, we find our unknowns. So let's go do a few examples so that all of this makes sense. Example 1 says that x is directly proportionate to y. When x is 15, y is 3. So the first step, if you go back to your steps that you should have written down, is write your proportional statement. Our proportional statement here is that x is directly proportionate to y, and it says that in the question. X proportionate y. The next step is to find the value of the constant. Now, before that, we do step 2, which is we replace the fish symbol with equals k. And then after that, we sub in for the variables. Now, it says here, when x is 15, y is 3. So when x is 15, y is 3. And you see I subbed them in. The next step after that is to get k by itself. So to get k by itself, it's times 3 at the moment. The inverse or opposite of times 3 is divided by 3. Whatever I do on one side, I have to do on the other. So now k K equals 15 divided by 3. And so now 15 divided by 3, K equals 5. I have found the value of my constant. The next step after that is to use this value of the constant and write my universal formula. Now that I know K is 5, I can sub that into where K was before. And so X and Y are variables, they will change, but K, my constant, will remain the same. So my universal formula is X equals 5Y. What do I use this formula for? Well, I use it now to find other unknowns for the same situation. And you'll see that in part D and E. So part D says, find what X is when Y is 9. I have a universal formula. It says find what X is, so X is still unknown, and Y is 9. So this Y is 9 value is going to go right there where that Y is right there. So now I have X equals 5 times 9, which equals 45. So quite simple to now find other unknowns when I have my universal formula. Let's go on to part E. Part E says, find what Y is when X is 2. So I still use my universal formula, but now X is 2, that's going to go there where that X is right there. So 2 equals 5Y. How do I get Y by itself? Well, that's 5 times Y. The inverse, or opposite of 5 times Y, is divided by 5. Whatever I do on one side, I must do on the other. So now, Y equals 2 divided by 5, which equals 0.4, or 2 divided by 5. We can leave it as a fraction. The reason I've written that as a decimal is because it's a terminating decimal. It stops. So you see here, I've done all of my steps separately, just so it makes sense. But sometimes the question will ask you to do the steps without saying what steps to do. And that's why it's so important that you write the steps down and you memorize them so that you can apply them to any question. Let's look at question 2. So question 2 is a case study. It gives us a scenario. The quantity of paint required for a job is directly proportionate to the area that needs to be painted. That's quite simple. If you have a certain area, it will require a certain amount of paint. If 8 liters of paint will be required for 70 meters squared, find. Okay, so they've given me some of the values of some of the variables, and they've given me what is proportional to what, so I can fill in all the steps now. Part A says, how many liters of paint will be needed for an area of 30 meters squared? Now, before I can do that, I need to find the value of the constant, and I need to find the universal formula. So let's go through those steps. First thing is, write your proportional statement. P, or paint, is proportionate to area. The quantity of paint is directly proportionate to the area. Second step, replace the fish symbol, or the proportionate symbol, with equals K. Done that. Next step, substitute the values from the question. They've told me that P is 8 liters and area is 70. So I have 8 equals K times 70. Next step, find the value of the constant by getting K by itself. So there's a times 70 with that. The inverse, or opposite of times 70, is divided by 70 on both sides. Now I have K, I can then sub that in to get my universal formula. And my universal formula in this case is P, or liters of paint, equals 4 over 35 times the area that is required. So now I can find how many liters of paint. Well, P is the unknown. So I know A is 30, I sub that in. P equals 4 over 35 times A, which is 30. Chuck that in the calculator. I get that I need 3.4285 liters. Now, because we're talking about paint here, and I'm going into the next liter, I can't say this is 3 liters in real life. I have to say it's 4 liters. because I will need another can of paint or another liter of paint. If I got 3 liters, it'll be 2 less. So I need to round that up to 4 liters. Let's go on to question B. Question B says, what area will be covered with 100 liters of paint? So now they've given me the P value, but they want to know the A value. So let's have a look at how we do that. Well, we start with our universal formula where P equals 4 over 35A. And that's why it's called a universal formula, because it'll apply to everything. It'll allow us to do any unknown for that question. So now we know P equals 100. So now all we do is we sub it into where it goes. So 100 equals 4 over 35A. So now we need to get A by itself. Well, that's 4 over 35 times A. So the inverse of 4 over 35 times A is to divide both sides by 4 over 35. When I do that, this cancels out, and I'm left with A equals 875 meters. Hopefully you're getting the hang of this with the examples that I've given. Now, I have a few questions here. Pause the video, do the questions, and then come back and look for the recommended answers. Okay, you should be done by now. Mark off your recommended answers. Hopefully you got them all right. If not, go through, watch the examples again. Till next time, take care, guys.